Okay. I felt like this lesson was pretty intense. I don't think I understood everything. I don't know about you guys. So, ready to get started?
Yeah.
Okay. Does somebody want to read question 1?
A hypothesis test consists of two hypotheses, the null hypothesis and the alternative hypothesis. Which one represents the status quo? And that is the null hypothesis.
Wait,
Okay.
where are you doing the quiz, or are you doing the assignment?
The quiz. Oh yeah, we
Oh,
should do.
okay. Did you guys? Yeah. Did you want to go over the answers, or do you just want to go to the quiz? I'm
We
fine
can
with
go over.
either.
So
What do you
for
want to do, Peter?
I don't know. Either one, it's fine. I mean, we could try to do the quiz.
All right. Well, what do you guys want to do? Just tell me.
let's get through the homework just to get through it.
Okay.
All right.
So the graduate management admission test is used as an admission criterion in many Masters of Business Administration programs. Score on the GMAT in the past have been a mean score of 529. The BYU professor feels now that the score has improved within the last couple of years. Determine the null and alternative hypotheses. So for that, I got the null is equal to 529, and then the mean is greater than and less than 529.
I just have the mean is greater than 529.
That one, yeah, I checked on, I didn't understand, why it was only one, because I thought,
Well, I think it's because of the last sentence. It says the BYU professor feels that the score has improved within the last couple of years. So since it's improved, he assumes it's greater.
okay.
Yeah.
Yeah. Otherwise, I think it would be just not equal to if it was just different. Okay. Are we good to move on?
Yeah.
Okay, I'll read B. Suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of the student taking the exam is still 529. Was a type 1 error or type 2 error committed? It was a type 1 error, right?
Yeah.
Because they rejected the null hypothesis, but it was still correct.
Yeah.
Okay.
So this is C. If the analysis was done at A equals 0.01 level, what is the probability of committing a type 1 error? Just a 1% chance that they would commit a type 1 error.
Yeah. I didn't really know why. Do you guys know why it's just 1%? Did they just, like, if it was 0.05, would it be 5% then?
Yeah, it talks about it under the type 1 error part of the notes.
Okay. All right.
So,
Okay.
Okay.
If we wanted to decrease the probability of making a type 2 error, would we need to increase or decrease the level of significance? So we would increase it.
What?
Increase.
Oh, okay.
that's what I
Yeah. So I'm not going to read that big old thing. I'll just read A.
Yeah, that's fine.
Design the study. What was the population for which the realtor obtained his data? How did he sample his population? And what is the research question? So he collected data from his own buyers, and then he just took 15 of his own clients. And then the research question is the average age of the people buying the properties in the area different from the national average? We all good there?
Yeah, I think so.
Okay. Peter, do you want to read B?
Sure. Collect the data. Name at least one way the realtor could have randomly selected his sample. I mean, he could have used random sampling, or or you could do what is it? The every, third or fifth, or I forget what that's called. Stratified?
Yeah. Was it stratified or systematic? I can't remember.
Oh no, it was just it was
Yeah, one of those.
Sure.
Okay.
And
All right.
the graph, it gets higher. So 5 descriptive statistics that could. I don't really know on that one. Kind of ways to describe it more. I guess just. You know.
Was yours left skewed?
It was, yeah.
Yep.
Okay. And then it just kind of fell in between 25 and 59, 58-ish, around there. Okay. So check the requirements. Since there are 15 pieces of data, well, you need to check the QQ plot to check for normality. Peter, you want to read the next one?
Yeah, state the null and alternative hypotheses. So the null hypothesis was or is 47, and the alternative hypothesis is, so it's a two-sided or two-tailed, and it's the same 47.
Yeah. So it's not equal to 47.
Yeah.
Okay.
Let the level of significance be alpha equals 0.05. Was that a question on here, or was it just something that...
No, it was just to let you know because you needed it for later.
Okay.
So, yeah, it was kind of weird how they just threw that there. So,
Yeah.
okay.
It looks like a question, yeah.
Yeah, so I'll read the next one. Compute the test statistic was the formula to be used. Down to the general formula, input the numbers you'll use. Yeah, so it's basically just finding the z-score, so x bar minus mu over sigma over square root of n. And this is where I got a different answer than what's on the answer key. I got 0.2068. And I don't know why I got a different answer than what he has. What did you guys get?
I got the right answer, the 0.20910. That's what it says on the answer key.
Can you guys see me or hear me?
Yep. I can hear you.
Okay. Yeah, I can't hear Victoria. But
Hey, I can hear you guys. Can you hear me now?
yeah.
Yeah.
Okay. So, what did you guys get for the z-score? For 4?
I got the right, I guess, the right answer. Let me look how I did this.
I'm gonna plug it in again just to make sure.
Okay, she went away. I don't know what's going on.
Yeah. Um.
Hey.
Hey, welcome back.
Good. You guys can hear me?
Yep.
Okay, good. Sorry, my internet's been really bad, so I'm sure it's my computer.
It's all good.
So I'm sorry you probably moved on, but what did you guys get for the z-score?
I was just recalculating it just to make sure. I got five- okay, this time I think I did it wrong. I got 0.04 and yeah. So I don't.
Yeah, so I don't know what I did that was different from what the teacher did. I just calculated the mean from the 15 numbers and then subtracted the mean. No, I got the mean that they gave us, then I subtracted the mean from the 15 numbers, and then I just used the standard deviation they give us over the score of 15. But I didn't get that z-score exactly. It was just 2.68. So I don't know.
Maybe it could have been from the rounding, but
Yeah, I'm not sure.
so I don't know because it doesn't. It gives you the full number, so
Yeah. Okay. Do you guys want to move on to 5?
sure.
So compute the p-value. First, sketch a standard or normal curve. Graph your test statistic along the horizontal axis. Shade the appropriate area under the curve. And so, kind of needed the z-score for this. So my answer is wrong since I didn't have like the correct z-score. But
Yeah.
yeah.
Yeah. So I just used the number they had in the on the answer key and I put it in and got that p-value too.
Yeah,
The
same.
other z-score Yeah, another z-score I got, it was a little bit bigger because my numbers were off, but just a little bit. Okay, so compare the p-value to the level of significance, the alpha level. Do you reject the null hypothesis or fail to reject the null hypothesis? So because the p-value is greater, so 0.08344 was greater than 0.05, we don't reject the null hypothesis, or we fail to reject the null hypothesis, whatever. Okay.
State your conclusions in terms of the alternative hypothesis. So we have enough evidence to conclude that the mean is different from the mean of buying a second home is different from the area or in this area than the national average. So
Yeah. So
And
insufficient evidence.
yeah.
Okay. Right.
okay, what
So
action
Chris.
do you suggest
Yeah.
the realtor to take based on your statistical conclusions? So just like for realtors to like study more people, or like the people that are like within that range, like 40s, like 40s, 40s to 50s, and like what kind of homes they're, or like I don't know, the people that buy homes.
Yeah. So you should just keep targeting that group of people.
Yeah.
Yeah. Okay. It sounds good. Do you guys want to start on the quiz now?
Yeah.
Yeah.
Okay. Well, I still remember what Krista said about the first one, how it's the null hypothesis. So, are we good, or do you want to go over that one again?
Sorry, I'm just getting on a hypothesis test. No, what one? So it would be the first one, or number 3 would be the null hypothesis.
Yeah.
Okay.
All right. I'll read number 4. Which hypothesis involves equality? The null hypothesis.
Yeah.
Yeah, because the alternative always has to be like not equal. So.
Yeah.
Um, Krista, do you want to read 5?
Yeah. When computing the probability, which hypothesis do you assume to be true? So, null hypothesis.
Yeah.
Okay, I can read 6. Suppose the null hypothesis equals 10. Use this information to answer questions 6 through 8. Which of the following represents the alternative hypothesis for a two-tailed test? So that would be the third one.
Okay. Which of the following represents the alternative hypothesis for a left tail test? It's the first one. Mu is less than 10, right?
Yeah.
And which of the following represents the alternative hypothesis for a right-tailed test? And that is B.
Okay.
The outcome of a hypothesis test is determined by comparing the p-value to the level of significance, or alpha uses information for questions 9 through 10. Which relationship would result in failing to reject the null hypothesis? Failing to reject. Let me go back to my notes.
Yeah, I have a hard time remembering.
Okay.
So if the p-value is less than the alpha, we reject the null.
If the p-value is less than the hypothesis,
So it's alpha, A.
so it would be the second one?
Yeah.
Okay.
At least that's what I got from the notes. Did you guys get anything else different?
No.
Okay. So which relationship will result in rejecting the null hypothesis? P-value is greater than alpha?
Yeah.
Yeah.
Wait, let's see here. So if the p-value is less than alpha, we reject the null. If the p-value is not less than alpha, we fail to reject the null. Did I get this confused?
So I think on number 9, its p-value is
Yeah, I think I switched those.
Okay. It's flip-flopped.
Yeah. Yeah, sorry.
You're good. I was confused on that too.
Okay.
So an insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim was about $1,500. They are concerned that the true mean is actually higher than this. Use this information for questions 11 through 12. So, which of the following would be the appropriate alternative hypothesis?
Would it be the average claim amount is greater than 1,500?
So the null is saying, well, I know this is alternative, but the null is saying, I'm thinking the null would be the average claim is equal to, and then the alternative would be greater than, I think.
Yeah, so for 11 we're finding the alternative.
Yeah. So that would be greater
So
than?
the average, yeah, that's what I think. And then 12, the average claim amount is equal to 1,500. Are you guys getting something different?
For 12?
for 11 and 12?
That's what I'm thinking. Because it looks like the null hypothesis is always equal to the hypothesis that it's giving you. So I
Yeah.
think
Okay.
we're good for 13?
Yeah.
Okay.
Whose turn is it?
I think it's Peter.
I can read it. That's fine with me. The insurance company randomly selects n equals 40 claims and calculates the sample mean. Sample mean x equals 1650. Use this information for questions 13 through 15. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption?
I put yes because
Yeah.
there's 40.
And that's pretty large.
Yeah.
Good number. So then for 14, would that be the central limit theorem, because the mean is normal, or
Good question. So you think it's the central limit theorem?
either that or the law of large numbers. Like, I don't want this to get mixed up. Sorry, stuff getting mixed up.
Yeah, I just can't remember
Yeah, I can't
which is
remember the
which.
exact definitions.
So I googled central limit theorem. It states that given certain conditions, the arithmetic mean of a sufficiently large number of iterates of some big words will be approximately normally distributed regardless.
Yeah, I mean, it seems more right than the large
Hello?
law.
Yeah. So you guys want to go? What do you think it is?
I'm thinking central limit theorem.
Me too.
Okay. All right. Sounds good. Okay. Which of the following is a test statistic as defined in this lesson? That's a good question. Do you guys know?
So this is 4.2 under the notes.
$4.2.
Yeah, that's like the number.
Oh. Yeah, I know. I was just surprised how detailed. You knew exactly where it was.
I was like 4.1, so I saw it and I was like, oh, it's 4.2.
So Z is the test statistic.
Yeah.
Yep. That's what it looks like.
Great. Yeah.
The historical
Okay.
mean of sales receipts at a grocery store is $150 with a standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the following hypothesis. mean equals $150 and mean is less than $150. She will use a level of significance of alpha equals 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes bar x equals $144. Use this information.
So, I don't know about you guys, but I got negative 0.9. I'll redo that, but yeah. Yeah, I still got negative 0.9. What did you guys get?
Yeah, I got negative 0.9 as well. That's all it gave me.
I'm still plugging it in, but I want to make sure like I'm doing it right. So the $40, take that and divide it by the 36, like square root of 36, and then above that you just have the 150 minus 144.
Okay, so you take x bar, 144, and you subtract the mean, 150, and then you hit equals, and then you divide by, what is it, 40, divided by 36, the square root of 36. That's how I got my answer.
Okay.
I think you had it backwards, Krista. You had the mean.
Oh, yeah.
You had the mean first, not the sample. Like it's the sample mean minus the mean.
Okay. So I just plugged that in. I got negative 0.025. So
You got what?
I got negative 0.025. I'll try it again.
Yeah.
Okay. So yeah, it's x bar 144 subtract 150 over 40 divided by the square root of 36.
Yeah, I still got the same answer. I'll try it on a different calculator, see if that changes anything.
Okay.
Yeah, I'm getting negative
909?
negative 0.89995, something like that. So you'd round it. I'd round it to negative 0.9.
For the second one, I got negative 0.909.
Yeah, I just got negative 0.9. I didn't have anything after it. So, yeah. It might be my calculator. I don't know. Yeah, I got negative 0.9. So,
That's what it rounds to. Even
So
if you
yeah.
use the whole number from the 40 divided by the square root of 36. So
Yeah. So what are you putting in your calculator? How do you do it? I'm just curious.
how do I do it?
No, Krista. How does Krista do it?
So I used a different calculator. I used the one on my computer instead. I don't know why this one didn't work for that problem. I guess it was too big for it. But I got the same answer. I got 0.9 and then a bunch of zeros. So, and then 9.
Okay. So 9 and a bunch of zeros and 9?
Yeah, it was like I think there was like 4 or 5 zeros in there.
Okay, so no matter what, you still get negative 0.9. So we're good.
Okay.
Okay. Um, whose turn is it for 17?
I can read it. What is the p-value associated with the z-score from the previous question?
So for this, do you have both sides highlighted?
I think that's what they
I'm
want.
pretty sure. Because it would be.
Yeah, that's what I was thinking too.
So you guys getting 0.3681 or 368?
Yeah, so 0. Yeah, yep.
Because you round to 3 decimal places.
That's what I got. Is that what you got? Yeah.
You said
So are we all good?
As long as we put it into the probability thing, right?
Okay. Are you guys ready for 18?
yeah.
Yep.
Okay, so what inference would you make about the null hypothesis for this problem? It's reject the null hypothesis, right? Or am I
Yeah.
wrong?
It's less than.
Because the... Oh wait, no, I think we failed to reject the null hypothesis. Sorry. Because the p-value is not less than alpha. We failed to reject the null. So, yeah, failed to reject the null hypothesis. Sorry, I have a really hard time with that. I don't know why.
Wait, it's because the p-value is larger than alpha or smaller? Oh, alpha is 0.05.
So if p-value is not less than alpha, so if it's bigger than alpha, we fail to reject the null.
Okay, that's confusing.
Yeah, the way they phrased it, I hate
Yeah,
it. Yeah, it
exactly.
makes me think like 10 times harder than you need to. Okay.
Okay. There are 2 types of errors to be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? This is type 2, I think.
Okay. A type 1 error is committed when we reject a null hypothesis that is, in reality, true.
Okay, never mind.
A type 2 error is committed. So, yeah, I think it's type 1.
Okay.
Right?
Yeah, according to the notes.
Okay.
Okay. A researcher We good for 20?
Yeah.
Okay, a researcher decided that instead of using a level of significance alpha equals 0.05, he will use alpha equals 0.01. Which of the following will be true? Jeez. Look at the types again.
So isn't it a type 2 will increase?
I was thinking it's one of the type 1 or type 2.
Yeah, the other two don't really make any sense. Because we're not rejecting the null hypothesis. But this is a little different.
Okay, so you guys think it's 2, right?
Yeah.
Yeah,
The probability of type 2.
if alpha is allowed to be very large, then the probability of committing a type 2 error will be very small, I guess.
Okay. If alpha equals 0.05, compute the probability of committing a type 1 error. Isn't that 5%?
Yeah.
Because yeah, it's not different, it's the same thing.
Yeah. Are you guys just gonna put 5 in there, or do you put like a percent sign?
It won't let me put a percent sign.
Yeah, I put 0.050.
Probably safer.
Yeah, I don't know. Okay. Did you guys submit it already, or do
I
you want
just
to go over anything?
looked it over.
I submitted it. We did pretty good. We just
Okay.
got 17 wrong.
How did we get that one wrong? Oh, we probably put in the shading wasn't correct or something.
Yeah.
But I don't
I
know.
wonder if because it was a negative z-score, we only shaded the...
Just the left side.
That's super weird.
Yeah.
Yeah. That's really weird. Okay, well, great job, you guys. I'll see you next Monday.
Yeah.
All right, sounds good. We'll see you guys.
Okay.
Bye, guys.
Bye. Bye.